All right, so for 2.5, it wants us to find all the commutators for all the combinations of the three operators, x, y, and z. So I did write those operators right here for reference. And as a reminder, to calculate the commutator for like a and b, it would be ab minus ba. And also, the book says that if you take a commutator for two of the operators, so let's say sx and sy, it should give you back I, h bar, the third operator, so sz in this case. So if we were to do z and y, we should get back I, h bar, sx. So let's see if we can make that happen. So start off with this first one here. So we're going to do this here. So sx, sy. So sx is here. So h bar over 2, 0, 1, 1, 0. Times our sy, which is here, h bar over 2, 0, negative I, positive I, and 0, minus, just flipped around, reversed. So h bar over 2, 0, minus I, positive I, 0, h bar over 2, and then this one here, 0, 1, 1, 0. All right, so let's combine these h bar over 2's. It's going to be squared. Okay, so then we have 0 times 0 is 0, plus I. And then we have 0 plus 0. We have 0 plus 0. And we have negative I plus 0, negative I. All right, then minus. Again, we'll combine these h bar over 2's. We have 0 plus negative I. There is 0 plus 0, 0 plus 0, and I plus 0. Now we can factor out this h bar over 2 squared. And we can do I minus negative I, which is going to be I plus I, would be 2I. 0 minus 0 is 0. 0 minus 0 is 0 again. And negative I minus another I would be negative 2I. So here we can factor out a 2I. So let's pull out a 2I. Let's go ahead and split up these two h bar over 2's. H bar over 2. And then we're left with, because we pulled out the 2I, we're left with 1, 0, 0, negative 1. And these 2's cancel. So we're left with I, h bar over 2, 1, 0, 0, negative 1. And this right here, this h bar over 2, 1, 0, 0, negative 1, that's our sz right there. So the first one here is, so we did sx and sy, and we got I, h bar, sz, like we expected. So that's good. So on the next one. First two are pretty easy. Last one's a little bit trickier. All right, so here we have sy, which is h bar over 2, 0, negative I, positive I, and 0. H bar over 2, we're doing sz for this one. So that's 1, 0, 0, negative 1, minus h bar over 2, 1, 0, 0, negative 1, and h bar over 2, 0, negative I, positive I, and 0. Yeah. I will let that marker recover. No, I think I'll keep on going. I don't know where my marker box is. So we'll factor this out. So h bar over 2 squared. Okay, we have 0 and 0. We have I and 0, positive I. There's 0 and negative 1 and negative I, make a positive I. and 0 and 0. Okay. Then factor out this again, h bar over 2 squared. And we have 0 and 0. 0 and negative 1 and I make a negative I. Oh, that's not right there, though. That's right here, negative I. Negative I and 0, make negative I. And 0 and 0. Okay, now we can factor out these h bar over 2's. And subtract. 0 minus 0 is 0. I minus negative I would be positive 2i. I minus negative I, again, be 2i. 0 minus 0 is 0. Okay. Let's pull out a 2i. So we have 2i, h bar over 2, h bar over 2, 0, 1, 1, 0. These 2's cancel out. And we're left with I, h bar over 2, 0, 1, 1, 0. And 0, 1, 1, 0 is our SX operator right here. So SY, SZ is I, H bar, SX. Okay, good. And now for the last one. Okay, so we have SZ, which is H bar over 2, 1, 0, 0, negative 1. H bar over 2, SX is 0, 1, 1, 0, minus h bar over 2, 0, 1, 1, 0, h bar over 2, 1, 0, 0, negative 1. Okay. Combine our h bar over 2's. Okay, 0 plus 0. 0 and negative 1, make negative 1. 1 and 0, make, I messed that up, didn't I? What did I just do? 0 and 0, make 0, 0 and negative 1, make negative 1 here. 1 and 0, make 1. And 0 and 0, make 0. Okay. H bar over 2 squared. Ooh, all right. 0 and 0, make 0. 1 and 0, make 1. 0 and negative 1, make negative 1. And 0 and 0, make 0. All right. Factor out our h bar over 2 squared. 0 minus 0 is 0. 1 minus negative 1 would be 2. Negative 1 minus another 1 would be negative 2. And 0. All right, let's pull out a 2. Let's do 2 h bar over 2, h bar over 2, 0, 1, negative 1, 0. Okay, and 2's cancel. And we're left with h bar over 2, 0, 1, negative 1, and 0. Okay, so we're looking for this here, and I don't see a match. So this is x, z and x. So we were expecting to get sy. That doesn't look like that, though. But one thing that you can do is you can actually pull out an I. Now, how do you know to do that? I mean, only because you're looking for sy and you're trying to get there. Now, this would be the valid commutator, but you could also pull out an I because if you were to do that, so we have this matrix right here, 0, 1, negative 1, and 0. And that would equal I. So how would you make a, these are going to be 0 no matter what. How do you make a 1? If you have an I, how do you make a 1? You can multiply it with a negative I, because I times negative I is 1. And then how do you get a negative 1 from an I? Well, I squared is negative 1, so I here. So I times negative I is going to be 1. I times I is going to be negative 1. What did I just say? I times negative I is going to be positive 1. I times I is going to be negative 1. So these two are the same. So you can go ahead and pull out an I. So then that would equal I h bar over 2, 0, negative I, 0. And then that does look like our sy here. So our sz, sx is indeed equal to I h bar sy. Okay, hope that helped. Last one's a little bit tricky just because of that pulling out that I, but hope that makes sense.